Alright, so I've gone ahead and I've created a whole bunch of parameters to hook up to the various options within our network, and I've done all those relative references. It would have been a pretty slow, boring video for you to watch me set up each and every one of these by hand. But I'll give you a quick run through of what all of these various parameters are hooked up to in the network. So as we saw in the demo for setting up these HDA items, the num cutters is relative referenced to the force total count of the scatter here. This cutter resolution is linked to the rows and columns for these grids. This seed is used in a whole bunch of places. I've wired that into the global seed on the scatter, to the global seed on the attribute randomize for the normals. I've also reworked the offsets a little bit for our low frequency noise. It seemed like the random function was not giving us the vector version. Not sure if I missed earlier that it wasn't or if something has changed, but I had to add this explicit cast wrapping this random function call within this vector in parentheses to force it to use the vector version. And I've also added a local variable for this offset multiplier. Now local variables just exist within this wrangle node, whereas attributes are created on the actual geometry and continue on with the geometry after the wrangle node. The difference being those attributes are added with this @ symbol, whereas just using a data type like float creates that local variable. This probably isn't super crucial since we would get different noise anyway by changing our incoming scatter, but I still like to vary as many things as possible whenever that seed value changes. And slightly more simple than that is the offset on the higher frequency mountain detail here. I've changed that offset to 100 times that seed value for both X, Y, and Z. Once again, probably less important for these noises since those will drastically change along with all the cutters, but still nice to keep all of that as random as possible. And we looked at this a little bit earlier when I talked about setting up these links, but I've created this add cutter ID toggle, which we're using down here like we saw earlier. And for the noise settings, as you can probably imagine, the large noise amplitude and size are linked to this attribute noise here for the element size and amplitude. And this float for the large noise octaves is linked to the max octaves on the fractal. Then moving on, we have the options related to the smaller scale detail. So if we jump down to the mountain, the amplitude and size are hooked up as you would expect, and the max octaves are slightly different. Because we're using a mountain for the smaller scale details, the max octaves for the mountain is an integer, not a float, which is why it's a little bit different in the way these parameters are set up. This one is a float slider, this is discrete integers. Also, a quick note on these fractal type options. I've flipped the mountain to just use a standard fractal type, but if you really want to finesse how the fractal type is applied to your small scale detail or the larger noise above, you can check out the help for the mountain SOP, and they do a pretty good job of explaining the differences between the different noise functions. Here you can see what the different noise patterns look like, which is quite cool. And this shows you what all the different fractal types look like with the standard versus terrain and so on and so forth. And if you want to get deeper into this, you can check out some of the options for lacunarity and roughness and etc. But typically I don't really need to mess with that stuff too much, and just the standard fractal type and normal size, height, and max octave options are generally enough for all the cases that I've run into. Getting back to the parameters, the add mesh subdivisions is an integer that is linked to the subdivide just before that small scale noise. And then we have our padding. So I have the upper and lower padding both set to 1, but I found that when you have really large objects, you might want a bit more padding. So I've set the bound expand here to be a channel reference to the lower padding here, to the lower padding there. Same thing with the upper padding, but I've also multiplied in, where it's channel referenced here, this padding mult parameter. Now, I've set the default value to this. If we look at our edit parameter interface and select the padding multiplier, this might be a little bit hard to see in here. Anyway, I've added it there. It's easier to read up here. This is getting a value for the bounding box Y size of our input geo, and it's multiplying that down to 0.1. So if we have an object that's 100 units tall, then this will grab a value of 10. But if we have really small input geometry, we don't want that to shrink our padding to nothing, so we want a padding multiplier of at least 1. So I've set the default value for this attribute to be a function. It's getting the max value of either 1 or 0.1 times the Y size. This is really an optional thing. You can always just leave out this padding multiplier if you don't want to mess with it, but I find it kind of nice for handling objects of different scales. And then finally, the last of the parameter set here, I've added this option to trim outside object, which is just activating that switch, which will run that little trim to object network there. And finally, this expand trim object is linked to this VDB reshape SDF here. Now for the VDB from polygons, as I mentioned before, this voxel size is something we have to watch out for. So I haven't made a parameter for this voxel size. You could put in some sort of a voxel size parameter if you would like to, but instead I just set this to a formula that would vary that voxel size based on the size of the input geometry. Let's bring that up in the parameter view so it's a little bit easier to read. This looks like a little bit of a mess visually, but it's not too complicated. I'm using a couple max functions to find the maximum dimension in x, y, or z of the object. So we have one max function that looks up the bbox for both z and x and returns the maximum of those, and then we're feeding that into another max function that will compare that result to the y size. So whatever that largest size is, it will multiply that by 0.005. So in this case we have a voxel size of just a little bit over 1, and it's giving us voxel dimensions of 137 by 128 by 205, which seems pretty reasonable, and hopefully this function will keep that approximate voxel size consistent regardless of how big the object is that's connected to this HDA. Now, one thing we haven't considered yet is how the size of our scattered grids should be affected by the size of our input. Now if we go back to our VDB from polygons, where I've taken that double max function lookup to find the maximum dimension in the input geometry, we can copy that and then use that for the size of the grid. So let's copy that max function lookup. In this case, it's finding a maximum dimension of 209. Whereas if we middle mouse click on our input geom, sure enough we can see that the Z size is the biggest at about 209 there. And just to make sure that these will be big enough, let's multiply that maximum return value by 3. And then we can copy that X size there and paste it into the second field there. Now this multiplier of 3 might seem really excessive, but if we take a look at our bounding shape, let's say that we have a scattered point here, and we have the worst case scenario of that extending out to the opposite corner. Now, this won't just extend from this corner, this is going to extend out this way as well. So we need a really big plane in order to make sure that something scattered in one far corner reaches all the way to the other side. Now, a multiplier of 2 won't be enough to ensure that that is big enough, and once we start applying all that low frequency noise, these things can be pushed around quite a bit as well, so that's why I generally stick with this multiplier of 3 as a good value to use.